Hello and welcome to my tutorial on transformations. I intend to do transformations on reflection, rotation, enlargement, and translation. Anyway, those are the ones that you have in mathematics, but we're going to be doing the first two in this current tutorial. In a following tutorial, I'll be showing you how to do enlargement and translation. So to begin with the reflection, let's begin with the first one. Reflection. Now, a few things to know about reflection. Reflection is defined by a mirror line. That means for reflection to be done, there has to be a mirror line. There has to be a mirror line to perform reflection. Another concept that is important for us to understand is that whenever we have reflected an object, the object and image collectively imply some sort of symmetry, and we're going to see that in actual examples. And to begin with, I have a simplified example here, and you might not be able to see the squares that I have on this figure here, but I'll use a Cartesian plane in the next example that I'll be able to show how exactly do that. But for a start, look at this triangle here. This triangle here is a right angle triangle. We have the middle line, which is the blue line, and so a basic question would be, where will this go if we rotated that? Sorry, if we reflected that along the blue line, where will the triangle go? Obviously, it'll go over here. Another thing we know about it is that it'll be overturned. Another thing maybe we should consider is that a point that is close to the middle line will also go closer. In the image, it'll be closer to the middle line as well. But points that are a little far from the middle line will also go further. In the object, they'll be further from the middle line. And so look at what we have here. We have the object, we have the image, we have the middle line. And so the points that are close to the middle line also comes close. The points that are a little far go a little far, and also the points that are a lot more far also go a lot far on the middle line. And so that's basically how it should be. The particular reason why I have set that first example there is because I want us to appreciate the basic concept of reflection. Whenever you have reflected an object, the image will be an overturned version of the object. The other thing is it will be as far from the middle line as the object was. Adding the size of the object and the image will be the same. It's important to note that. And maybe let me show you the aspect of symmetry in the next example. Sorry, in the next slide. Now I have overturned, or I've kind of turned that page that you're having on the previous slide there, to show you this here. It's the same, and please note here, the blue line is as though it's a line of symmetry along which, if we folded this, if this was a piece of paper and we folded it, this side, the whole of this side, would overlie on the other side, so exactly such that any point here will have a corresponding point. This point, if it was part of the object, goes to this point, which is a corresponding part in the image. The same case applies. So this point will lie over this one, and this one over this one. Even this particular line will lie over that particular line. This particular line also will lie over that other line. That tells you something. Whenever we are reflecting, object and image combined normally form some sort of symmetry, and the line of symmetry happens to be the middle line. So the reason why that is important is because we can always cross-check our work. If what you have, or having done the reflection, does not show symmetry, you might be wrong, and so maybe that's important to know. Let's consider an actual example of the Cartesian plane. Now this one happens to have a grid line, so you'll be able to see that we have a triangle ABC. The coordinates are given. The requirement is reflect that triangle ABC on the line y is equals to 1. And let's see what happens. Solution number 1, we should be able to draw the middle line y is equals to 1. Please allow me, I'm not going to get into showing how to draw that, but it should be understood at this point, because this concept is a lot more advanced than the concept where how to draw lines on the Cartesian plane is tackled. So you should be able to draw that line at this point. The next thing is that we should be able to reflect the points A, B, and C, and of course to get the corresponding points A prime, B prime, C prime. And this is my solution. We had the triangle ABC, and so that becomes A, B, C, all of them primes. And anyway, I don't know what you can see over there, but the basic concept that I had said in the previous example are seen here. This triangle is overturned and it falls over here to become A prime, B prime, C prime. Again, the points that are close to the middle line, this is our middle line. The points that are close to the middle line also happen to be close to the middle line in the image. The points that are a little far on the middle line, so from the middle line or from the object, sorry, the points of the object that are close to the middle line also happen to be far in the image from the middle line. So please consider that. Anyway, let's look at that in the next slide. Now please consider the following lines: A prime, A prime, B prime, and C prime. That is a blue line, the green line, sorry, the green broken lines over there. And I want us to make some inferences out of that. Number one, the lines A prime, B prime, and C prime are all parallel, and I hope you can see that. The line A to A prime, B to B prime, and C to C prime are parallel. That means whenever you have rotated an object to get an image, lines from a point on the object to the corresponding point on the image will always, all of them, be parallel. The points A prime, B prime, C prime, if we had other points, say D prime, E prime, and so forth, they would all of them be parallel. If they are not parallel, something is not okay. You have not reflected properly. So please consider that. The lines A prime, B prime, and C prime are all parallel. That should be the case in all cases when we have done reflection. Another inference to make is that they are all of them, these lines just mentioned, A prime, B prime, and C prime, they are all perpendicular to the line y is equals to 1, our middle line. And I'm sorry, this spelling here is not okay. I was meaning perpendicular, so please don't consider that. These lines A prime, B prime, and C prime, they're all perpendicular. They are simultaneously perpendicular to the middle line. That is important to note. As a matter of fact, if we were having A, B, C, and A prime, B prime, C prime, and then we are told to look for the middle line, we just need to connect the point A to A prime and bisect, or B prime and bisect, and or C prime, any of them, and bisect. You'll be able to get the middle line. That tells you something. Whenever we have an object and middle line, whenever we have an object in the image and of course the middle line will always be a perpendicular bisector of the points, a line connecting corresponding points on the object and image, like the point A prime, B prime, and C prime. I hope you notice that. That can always help you know if your work is well done. Another thing to consider is that the points, the x coordinates in the triangle ABC do not change, so that in the point A, the x coordinate was 5, and even here the x coordinate is 5. The x coordinate for B was 2. It's also 2 here in B prime. The same case for C. The x coordinate was 7, and it's also 7. So they don't change. The reason is because our middle line is horizontal. That means a point A, when reflected, A prime goes just below, not to the right or to the left or from the point A. So it's just below. Just the same case for B and C. That will not be the case when we are reflecting points using a middle line that's not horizontal. And so you should take care in that case. Now, I took this kind of a middle line, that's a horizontal line, because it's very popular kind of question, and will be able to present the whole information, also the concept. You'll be able to see the concept that you should get when you're reflecting. The whole idea of the concept I'm showing in transformations is that you can always see how, when transformed, the image should look like. So this is so much applicable even when we have a different sort of middle line. I think, having said that, we turn to the next part to see yes, there's another concept here we should notice. The triangle is overturned. ABC is overturned, and that's important to note. ABC is overturned to get A prime, B prime, C prime. Let's look at symmetry of the same thing. If you look at this object and the image, this is object and this is image. I have turned the Cartesian plane. I've rotated through 90. So look at the whole of this, the whole of that part in the display of your screen. This is a diagram, or it's a diagram or picture that is symmetrical, such that if this was a piece of paper and we fold along the blue line, this part would lie exactly over here, such that B would lie on B prime, C would lie on C prime, A would lie on A prime, this line here would lie on this other line, and every line here would have a corresponding line here. That is something we should always notice. Whenever we have done a reflection, some symmetry is always observable on the image, the diagram, and on the image, such that the object and the image has symmetrical points along the mirror line. The mirror line is the line of symmetry. It's important to notice that. Let's go to the next transformation, that is rotation. Now, rotation is defined by center of rotation and angle of rotation. That is so important for us to note. Rotation, for it to happen, we must have a center of rotation. We also must have an angle of rotation. The center of rotation is for the point about which rotation is happening. And this spelling is also not okay. I'm just noticing it is we're not supposed to have that R there. The angle of rotation is angle through which rotation is happening. It can be positive, negative, or whatever it is, and I'm going to show that in an actual example. So let's turn to an actual example. We have a triangle, a right angle triangle, that is a red angle, the red triangle there, and the point X. And so the requirement here is rotate that given triangle on the given point, and our angle of rotation is negative 90. So where will it go? I need to define what negative 90 means, and let me say this. Whenever we are rotating anything in mathematics, going clockwise like that is negative. That is negative. That's very important to notice. And when we are going anti-clockwise, that is the opposite of how the clock goes, the angle is always considered positive. The angle is considered positive. So in our case, since we are doing a negative rotation, it is supposed to be anti-clockwise. That is important, very important to notice. So where does it go? And here it is. I have just noticed that the grid lines that I have that are displayed here are not possible for you to be seen on your screen, probably because of the resolution or some other reason, I don't know. But I'm going to consider an example next after this, which will have the grid lines, and we'll be able to appreciate what I'm saying there. Generally, however, we should look at this. This is our object, and this here is our image. And what do you notice? This point here, which is a point on the object, rotated, comes to this point, such that an angle drawn that way would be 90. And it's negative 90 because we are going, so yes, negative 90 because we are going we are going clockwise. The same thing, this point rotated about the center of rotation comes to this point, and that angle, as angle made by the yellow line there, would be 90. The same case applies to this point and this point connected by broken green lines. So that's a basic idea you should know. Maybe it's important for me to mention that the triangles remain the same size, only that the orientation changes. Every point of this triangle turns through negative 90 to get the corresponding one there. Important to note. The other thing that you will see maybe in the Cartesian plane is that if we have squares here, we can always look at the points on the image as though it's a diagonal of a number of given squares, and that concept is important for us to see how to rotate. And let's consider this example. Maybe we have a triangle PQR. The center of rotation is the origin, and the angle of rotation is positive 90. That means we're going anti-clockwise. In your mind, you should be having a picture of where the triangle PQR goes. In other words, where will be P prime? What about Q prime? What about R prime? And this is my solution. Now, we need to look at a few things here. The point P can be looked at as though it's a diagonal of 1 by 7 squares. The point Q is also a diagonal of 1 by 2. The point R is also a diagonal of 4 by 2. What about when they have been rotated through positive 90? Because it is anti-clockwise, the point P goes to become a diagonal of 7 by 1. Such that if this is a graph paper, the angle P to center of rotation to P prime, that angle is positive 90, and is a diagonal of 1 by 7. The diagonal of 1 by 2 happens to come to become a diagonal of 2 by 1. So that Q to Q prime is as shown there. and the same case applies for R. What I find really important for us to notice, and I know that different people will explain differently, you can always look at rotation of a point on the Cartesian plane as though it's a diagonal of a given number of squares. And so that makes it a lot easier than it would have been if you don't consider that. I know sometimes students are advised to use a geometrical instrument, say a ruler or a compass, to draw, but I think if you use squares, it's more accurate, especially in cases where the squares are not perfect. And a lot of graph papers are not very accurate squares. So if you use squares, like look at diagonals or geometrical shapes that are represented, it's easier to see where the object goes to get the image. So please consider that. The point P is a diagonal of 1 by 7. When rotated through negative 90, it becomes a diagonal of 7 by 1, and the others, as I said earlier. However, what would be the answer if the angle of rotation was, say, negative 90? It was negative 90. This 7, since it's a diagonal of 1 by 7, it would come to be a diagonal of 7 by 1. So it would be just where we have 7 next here and just below there. Where would this line go? The point R, where would it go? It would be a diagonal of, I think, 2 by 4. And we can always get, even the point Q will be easy to see. Let me say this. If you use that concept of a diagonal of a number given squares, it will be easier. Maybe I should just end it at that. Now, if we are rotating this about negative 180, which is the same as positive 180, by the way, the point QR would just go, we just progress on the opposite direction, such that we just go also 1 by 7. So wherever that diagonal will go, 1 by 7 will be the answer for P prime. Q prime will go also to be, since here it is a 1 by 2, it will go to be 1 by 2 again. The point R, which was 4 by 2, will go to become also 4 by 2 again. So it'll just be a continuation of this blue line to get its image, the image of R, the continuation of this navy blue line to get the point QR prime, and continuation of this yellow line to get that. And that's important to note. Maybe I should have mentioned also that every point of the object turns through the same angle. And that's the end of my tutorial. Please check out soon. I'm going to be releasing the transformations of enlargement and translation. And I hope you learn. Always remember to like, subscribe, and share. Thanks.